Right, here we are given points QSR that are in the same horizontal plane, as we can see them, whereby QR is equal to SR. Therefore, it means this side is also X. They are in the same horizontal plane. Then here we have P, which is vertically above Q, which means it's on the vertical plane. P, S, and Q is on a vertical plane, such that PQ makes an angle of 90 degrees with QS. This angle here is beta, and the angle alpha, which is on the horizontal plane, angle alpha is actually on the horizontal plane. We are required to prove that H is equals to X into square root of 2 into X plus cos 2 alpha tan beta. So in this case, for us to be able to find H, we are saying that, can you see that we have H there, which is opposite our angle, and somehow because of this angle, triangle on the horizontal plane, we can make use of QS. QS is adjacent to beta. H is opposite to beta, which means we make use of tan. That is in this case to say tan beta is equals to opposite, that is H, over our adjacent QS. Since we are looking for H, it therefore means that H is equals to QS multiplied by tan of beta. Therefore, we now have to look for QS. As you can see there, can you see we are looking for QS? Looking at where we are going, can you see we even have a square root and a cos of 2 alpha, which means we are making use of cosine rule. And can you see that cosine rule, it also works because I have QS, this angle is alpha, this side is X, that is X, which means this angle is also alpha. And therefore this angle becomes 180 minus 2 alpha. Therefore, going forward, it means I must make use of the cosine rule. So that means to say, it now means here QS squared is equals to this side, that is my X, it will be X squared plus X squared minus 2 of this side times this side, that is X multiplied by X multiplied by cos of the angle that we are having there, which is 180 minus 2 alpha, which now implies to say the QS squared is equals to X squared plus X squared, it gives me 2X squared minus X times X, that is 2X squared multiplied by cos of 180 minus 2 alpha, which in this case now implies that QS squared is equals to 2X squared minus 2X squared. If you look at cos 180 minus alpha, it's in quadrant number 2, and in that quadrant cos is negative. So which means it will be multiplied by minus cos of 2 alpha. Then multiplying this to this, it becomes positive, which in this case implies that QS squared is equals to 2X squared. Minus times a minus, it becomes a plus 2X squared cos of 2 alpha. From there, 2X squared becomes a common factor, which implies that QS squared is equals to 2X open bracket 1 plus cos 2 alpha is 2x squared in this case. Now we want to make QS the subject. That is to say, we square root both sides. If I square root this side, it becomes QS is equals to, I put a square root on this side, it means x squared becomes x. Therefore, it will be x into square root of 2 into 1 plus cos of 2 alpha. Now from there, I must be able to substitute back. That is to say, my QS, in place of QS, I write it here where there is QS to be able to find H. Therefore, it implies there that H will now be equals to QS, which is exactly that. That is, it will be x into square root of 2 open bracket 1 plus cos of 2 alpha close bracket multiplied by tan of beta. That's how we come up to prove that one. Thank you so much. God bless you.